So up to now we already have covered the group index value, GI value, how to find out the GI value, how will you use it, how will you find out the GI value, that means group index value, and by the group index value, by the calculation, whatever value you are getting, from that value how to choose the subgrade material. So now I will explain on another topic that is very much important for soil subgrade preparation, that is CBR, that means California bearing ratio. California bearing ratio. Okay, so this is a value, and to find out this value the CBR test is done. That's why CBR test and CBR value, two different words are spoken to the students. So what is this CBR? What is this CBR? So I will tell you. CBR means, you people know how a standard stone aggregate for the RCC construction or any kind of construction for making concrete, you use the quartz aggregate, that is stone. So you know, or you can assume, or you can think about the strength of the stone, so how much tough it is. That means the toughness, the durability, the strength of a stone aggregate is too much good in respect of soil quality. You know, the soil is a very fine or very smooth or very weak type of material. If you look into the particular one soil material with respect to a one stone material, right? So stone aggregate, in this case stone aggregate, we can take it as a standard value or the higher value. Why? Because you people know from the geological concept, all the stones converted into the soil by the weathering action throughout this world, and all the soils by the weathering action again converted into the stone or the aggregate. So there is a relation between, internal relation between stone and soil. Soil is the weakest part and the strongest part is the stone. That's why we will assume the standard stone aggregate as the reference one, as the upper limit for the reference. How? In the case of California bearing ratio, I will tell you, actually this is a strength parameter for the soil. It will explain you the strength parameter of the soil. So in the California bearing ratio, you have two options. One is for standard stone aggregate, which you have taken for reference one, and the second one is the soil material which you are going to test, or which is going to be tested, whatever. So whatever soil you are taking, or whatever soil you are using for the road construction for subgrade preparation, so you will have to take some sample from there. So you know the mold. In the laboratory there will be a mold. In the mold you will have to compact it in 3 equal layers. You people already have known how to pour it. 3 equal layer, one layer, first pour it, then compact it properly, again pour it, compact it, again pour it, compact it. So total whole layer of the mold will be compacted by the soil. Which soil? That soil, or which soil is going to be used for the subgrade preparation. That soil you will have to use here. Okay, so now what will you do? After this compaction, you will have to apply some load. So after applying the load, you will have to check how much penetration is occurring. You will have to apply the load and you will have to measure the penetration value, or after each applying of each increment of pressure or each increment of load, how much penetration is occurring, right? Suppose initially you are giving 1 Newton load, say for example. So how much penetration is occurring, you have noted. Again you are in, and by machinery, by the machine, automatically the pressure is increasing, increment of pressure is happening. So within certain time the load is too 2 Newton. So accordingly 2 Newton, how much penetration level is there, that we have noted. For 3 Newton, how much penetration is, okay. So in this way, according to the load value, applying load value, how much penetration is occurring, that we will have to measure. Okay, and same thing happens, remember and try to think about the thing. The same thing happens for the road also. While heavy vehicles or heavy loaded vehicles or any kind of vehicles is passing through the pavement, that means load is applying, and due to that load, how much penetration is occurring, that depends on the soil strength. If the soil have proper strength, it will not penetrate up to a certain value. The penetration limit will be very less for the strengthy soil, but for a poor soil, the penetration value will be too much high. That's why we are comparing, or we are doing a test, or we are finding out a value which is depend on two parameter, that is, remember, that is load and the penetration. Accordingly, load, how much penetration is occurring, that is very much important. So I will go through the actual definition of the CBR value. So let's have a look. So CBR value means, that means California bearing ratio. I already have told you, California bearing ratio is a ratio. In the name you can heard the ratio term, California bearing ratio. So ratio means always there should be two parameter. The first parameter, which will be at the upper layer, that means in the numerator. In the numerator, the value will be the load sustained by the specimen. The load sustained by the specimen at 2.5 mm or 5 mm penetration, divided by load sustained by the standard stone aggregate at 2.5 mm or 5 mm penetration. So what is this? As I told you, standard stone aggregate is a reference one. For the reference, why we are taking the reference, I already have told you. For the reference purpose, we have taken the standard stone aggregates. So in same way, we will have to fill the mold with the standard stone in 3 equal layer, in which way we have filled the soil in the mold. So after filling, what will you do? We will apply the load and how much penetration is occurring. So there are two reference penetration value, that is 2.5 mm and 5 mm. So as we are applying load, some penetration is occurring. If we think it reversely, for this amount of penetration, how much load is needed? For this much amount of penetration, how much load is needed? For standard stone aggregate, as per IRC, Indian Road Concrete, it is given to you, because throughout the country for all kind of standard stone aggregate, strength is nearly same, is varying very less value. So you can take it as a standard value. That's why IRC is giving you the reference or recommended values. That is, if you are filling a mold and if we are applying the load and penetration is occurring, always, of course, for any kind of structural elements, due to the load, penetration or the deflection will occur. But the amount of deflection or penetration varies from structure to structure, strength to strength, it varies. So while you are filling the mold with standard stone aggregate, for 2.5 mm penetration, that is this much, for 2.5 mm penetration, the load is needed 1370, that means 1370 kg. And for 5 mm penetration, the value is 2055 kg, that means 2055 kg. This is the standard value. So now you will know, with respect to the soil, standard stone aggregate have good strength, higher strength. So to penetrate a stone aggregate for 2.5 mm penetration, 1370 kg load is required. So do you think, so for any kind of soil for 2.5 mm penetration, this amount of load will be needed? Of course not, because soil has less strength than the stone aggregate. That's why 1370 kg load is not required. Few less amount of load is required. Say for example 500 kg, 400 kg, 800 kg, 1000 kg. By this amount of load, that amount of penetration, that means 2.5 mm penetration will occur. Okay, so in this way we will have to find out the CBR value that I have told, load sustained by the specimen. Sustained means it can take it, you can take it, and the proper compaction, that means 2.5 mm penetration will occur due to that load. That load you will have to take from the test. While you are doing the test, you will measure the load from the probing ring, which measures the amount of load, and there will be a dial gauge which will measure the deflection or the penetration. So in the dial gauge, when you will see there is 2.5 mm penetration, immediately note down the corresponding load. So that load is required for that soil for 2.5 mm penetration. And when the penetration level is 5 mm in the dial gauge, immediately note down the value from the probing ring, which will give you the load required for 5 mm penetration. So these two value you will have, and the standard 2 value, that means 1370 kg for 2.5 mm penetration, for which one? Standard stone aggregate that you have known, and 2055 kg for 5 mm penetration. These two value is given by the IRC. So one for 1370 corresponding to 2.5 mm penetration, you know, that means suppose, say for example, you are doing a test on a soil which is required 500 kg amount of load, 500 kg F kilogram force amount of force is required or pressure is required to do 2.5 mm penetration. So what will be the CBR value? It's very simple. 500 kg, that means that is the load sustained by the specimen for 2.5 mm penetration, divide by load sustained by the standard stone aggregate. So for standard stone aggregate, how much it's needed? 1370. So the CBR value will be 500 divided by 1370 into 100 to get the value in percentage format. So it will be simply 500 by 1370 into 100. This CBR value will be corresponding to 2.5 mm penetration, as we have taken the load value corresponding to 2.5 mm penetration. Now, by the side, your test is going on. So after certain time, you will observe, you will notice that 5 mm penetration is going to be occurred. So immediately, while 5 mm penetration is occurring, immediately note down the load. Suppose you have noted down the load is, say for example 1400 kg or 1300 kg, say for 1300 kg. That means that soil sample is required 1300 kg load to do 5 mm penetration. And standard stone aggregate, for standard stone aggregate, this value is required 2055 kg. So CBR value at 5 mm penetration will be 1300 divided by 2055 into 100. So in this way we will find out the CBR value, California bearing ratio. So I will show a simple video. It's not made by me, it's made by someone. It's uploaded in YouTube. Just it's required for this kind of explanation, this kind of lecture. I will show you how to do the California bearing ratio test in the laboratory. So let's have a look. Let's have a look into the CBR test, how in the laboratory the CBR test is performing. I will tell you how the test is performing in the laboratory. This is the mold, they are compacting. This is the probing ring. This one is the dial gauge. This one is the probing ring. This is a load. This is the soil. So in this way you will have to take the soil. So after taking this soil, what you will have to do, I will tell you. They are applying some water so as to mix the soil properly. This is the mold, this is the base plate, this is the collar of the mold. They have fitted it, they are pouring the soil into the mold, and this is the compaction hammer. They are compacting the soil properly. The collar is removed, the top layer is cleaned up. Then the mold is reversed and there is a gap. You can see they are applying a filter paper here, and over the filter paper they have fixed up one load and they are soaking it into the water. This soak has to be done for 24 hours. This type of CBR test is called soaked CBR, so that you can take the effect of water into the soil. If you want to do the test without water, you can do that. That test will be known as unsoaked CBR. This is they are doing. So here you can see this is the dial gauge. This will measure the penetration, and this is the probing ring. This will measure the load. So they are applying the load. They will apply the load. This is the machine. Here is the gear. They are setting the gear, and the machine will run into a particular range, that is 1.25 mm per minute. That means within 1 minute 1.25 mm penetration will occur. So this is the dial gauge, this is the probing ring, this will measure the load. So they are applying the load, here you will measure the penetration. So you can see there is a graph, load versus penetration, right? So in this load versus penetration, for corresponding load, corresponding penetration values has been noted down, right? So in this graph, from this graph, corresponding to the, here you can see 2 mm. This is the 4 mm. So this is 3 mm. Here will be 2.5 mm. So corresponding to 2.5 mm penetration, how much load there? Sorry, this is 2.5 mm. Corresponding to 2.5 mm penetration, how much load is required, that we will have to find out from the graph. And corresponding to 5 mm penetration, how much load is required, that is we will have to find out from the graph. So these two values you will have in your hand, and by the formula whatever I told you, corresponding to 2.5 mm penetration value, that value divide by 1370 into 100, that will be the CBR value in percentage format at 2.5 mm penetration, and the CBR value for 5 mm penetration will be amount of load required for 5 mm penetration divided by 2055 kg into 100. So students, if you have any kind of questions, query about the CBR value and also the group index value that I already have covered. So regarding group index and regarding CBR value of the soil, any kind of question query, you just noted it. You can write it in the comment box of this video. You can do the WhatsApp, you can do a personal call to me, any kind of contact. So have a good day. Thank you.